Hey, yesterday we talked about how to find critical numbers and how to find how to graphically look at absolute max and min. Today we're going to take a look at what's called the extreme value theorem. And we're going to be asked to do this quite a bit on the AP. Remember, this is about 40% of the AP, where you're going to see something about in this unit here. So let's start. Let's say the extreme value theorem, or the EVT. If f is a continuous function, we kind of talked about that yesterday, where this function has to be continuous, on a closed interval, then the function must contain an absolute max or minimum. And that's pretty easy. If I kind of draw a little graph right here, no matter how I draw this graph, at some point it's going to have an absolute maximum, and at some point it's going to have an absolute minimum, as long as it's continuous. To find these, we're going to look at one of two places on a graph, a critical number or an endpoint. Now watch how I show my work here. This is really easy to do. It's basically writing a table. Say hello to your new best friend. The candidates test, or the closed interval method for finding extrema. Candidates test is fine enough. So to find the extrema, this is what we're going to do. We are going to find the values of the function at the critical numbers. Remember the critical numbers? These are where the derivative is 0 or does not exist. And then we're going to take a look at the values of the endpoints. And they're going to give us the endpoints for every single one of these. So that's not going to be terribly too tough for us. They're going to give us the endpoints. And then we're just going to compare. Remember, we're looking for the absolutes, the biggest and the smallest values. So let's look at an example right here. We want to find the absolute maximum and minimum values of f on this given interval. So the first thing we're going to do is we're going to find the critical numbers. Now notice they give us an interval. These are the endpoints. So when we take the derivative, we would get f prime of x equals 24 x squared minus 6x minus 9. I'm going to go ahead and find my critical numbers. Where does the derivative equal 0? Where does the derivative not exist? So to find out where the derivative does not exist, that's pretty easy. I could just look at this and say, well, this is a parabola. There is no domain restrictions there, so that's not going to happen. And then I can set my derivative equal to 0. Now right away, I'm going to divide everything by 3, just to make it a little bit easier for me. I would get 8x squared minus 2x minus 3 equals 0. And I'm going to have to factor. So when we factor, we're going to get, let's see here, this becomes 2x, 4x. I want to get 2 there, so that's going to make that what? 3 and 1. Let me check. This becomes, might make this a negative 6x plus 4, that gives me my negative 2, equals a 0, and we get x equals negative 1 half and positive 3/4. So those are my two critical numbers. Now next, I have to look at the endpoints. Remember, critical numbers first and then endpoints. Remember, critical numbers first, and now we're going to look at the endpoints. Notice, I don't start in the middle. I'm starting off at the far left, and I'm going to work my way to the right. Looking at the endpoints, they gave us negative 1 and 2. Okay, that was easy. Now we're going to use something called the candidates test to test them. It's basically just a table. Okay, this is the easy way to write it. We have x, and you're looking at the value of the function. Remember, we're going to look for the values. Okay, it's called the candidates test. And the function was the original 8x cubed minus 3x squared minus 9x plus 2. Now we're going to need a calculator for this one. So you might want to have one handy. I got mine right here, my Inspire. I feel inspired. Okay, let me clear out everything. Doc B, just clear that out. So in my table, the first thing I'm going to list is all my endpoints. Negative 1 all the way to 2. In the middle, I put my critical numbers. Negative 1/2 and 3/4. And I'm just going to find the values at those places. So the first one, of course, is negative 1. Now there are ways we can do this. I think the easiest way, personally, is to graph the function 8 x cubed to the third minus 3x squared minus 9x plus 2. Now, if you don't have a graphing calculator, that's fine. But this is, I think, the easiest way to do it. Hit enter, and I'm just going to find their values. I'm going to get rid of the label, highlight that, delete. And to find the values, I just go to Menu, Trace. I want to do Graph Trace, and all I got to do is I just put my x values in. -1, it gives me 0. See the point, -1, 0. Plug in -0.5. I just type it in now, and I get 4.75. Type in 3/4. I just have to type in 3 divided by 4. And I get -3.06. It actually does go further, 3.0625. But apparently I didn't change my the number of decimal places I go out there. And I just type in 2. And I get 36. And now I compare them. Well, where is my absolute maximum? I can just look at that. The absolute max at, where's the point? 236. There is my absolute maximum. Where is my absolute minimum? It's at the point 3/4 -3.0625. There it is. Ran out of room there. Sorry about that. And that's all we have to do. Now, if you want to put down a justification, the AP is not so big on this anymore. You can say by candidates test. And if you say by EVT, that's okay too, extreme value theorem. But candidates test is fine. But you don't have to put this down anymore. Okay? And that's how we find the absolute max and minimum. Find the critical numbers, find the endpoints, test all of their values, and then you're going to look at it. So what happens, like this is what my graph kind of looks like. So if I want to find the absolute maximum, once that's not on the domain, it kind of looks more like this. There we go. So if I want to find my absolute maximum, they can either occur at an endpoint or they will occur at critical numbers. That's the only places that they can occur. And that's what this kind of tells us right there. All right, so let's take a look at another example real fast. Oh no, let's get Trigalicious with it. So anytime we deal with trig functions, of course, that always complicates life. So we're going to so the first thing we have to find, if I'm looking for it, I need to find my critical numbers. So when we take our derivative, we're going to get 1 minus 2 cosine of x. Okay, I set my derivative equal to 0, and I'm looking for where my derivative does not exist. Well, there's nowhere where cosine does not exist, so I don't have to worry about that. I still show it because I like to show the AP. I know what I'm looking for. For where it's equal to 0, we're going to get cosine of x equals 1/2. And we know where cosine equals 1/2, pi over 3 and 5 pi over 3. So those are my critical numbers. Next, we have to look at the endpoints. And they're going to give them to you. They have to. They are x equals 0, x equals 2 pi. My favorite mathematical wrapper. Until he was shot by the big E. Next, after we get all that, we're going to look at our candidates test. Now look how long this is taking me. This doesn't take long to show all of your work. In doing the candidates test, make your table, x and your function. Remember our function this time is this x minus 2 sine of x. And plug in your endpoints 0, 2 pi, and your critical numbers in the middle. Pi over 3, 5 pi over 3. And again, use a calculator to get these values here. Especially with trig functions, they never really work out too nice for us. So I'm just going to plug these into here. And again, I think personally the best way is to graph it. But first, let me clear this out. Doc B. I always think personally is the best way. If they give you a calculator, use it, type it in your graph. X minus 2 trig sine x. Please make sure you are in radian mode. Press enter. Oh, there's my graph. All right, so I'm going to find the values. So I'll go trace. So to get the values on the calculator, on the Inspire, you're just going to go to Menu, Trace, and then Graph Trace. That's it. Very quickly. Graph Trace, and I just type in my numbers. 0, 0, pi over 3. I never find the pi button, but these calculators are cool. I can just type in the word pi, P-I, divided by 3. Whoops, escape, enter. And I get negative 0.685. And to do 5 pi over 3, 5 pi divided by 3. Same way. I don't ever know what the pi button is. And I get 6.97. And I go 2 pi, 2 pi, 2 pi. I get 6.28. Man, if you just look at these in fraction notation, these would be really hard to tell. But that's why the calculator is nice. If they say you can use a calculator, use the calculator. So now I can get my absolute max and mins. My absolute maximum, and sometimes I write it this way, will occur at the point 5 pi over 3, 6.97. My absolute minimum will occur at pi over 3, negative 0.685. And those are my answers right there. All right, very easy to do. Remember, what we're doing is we're looking, this is a graph. Remember what this graph looks like right here. Okay? Remember what this graph looks like. We're trying to find between 0, if I restrict that domain, let me go ahead and restrict that domain here. Window. Let me go setting, window settings. Window settings. If I go from 0 to, what was it? 2 pi. Hit enter. Here's my graph. What we're looking for is on this graph, where does that maximum and minimum occur? I can look, oh look, there's my minimum value, it's my smallest point, and there's my absolute tallest point. And now we have them. But remember, what we're saying is, if there's an absolute max or min, it has to occur at either an endpoint or at one of the turnarounds. That's really what a critical number is finding for me. It's the turnaround point. Turnaround. All right. So let me go on to number 3, and we'll take a look at a few more with us. Okay? I'll see you then.